Hello viewers, welcome to my channel. I am Dr. Leela bringing you lecture series on signals and systems and Python. This is my fifth lecture on amplitude modification of discrete time signals. Let us have a quick recap of what is covered in the fourth lecture. We have seen amplitude transformation of continuous time signals. So what are those operations? Amplitude scaling, addition of signals, multiplication of signals. And also we have found a relation between step and impulse signal. Impulse signal as a differentiation of step signal we have derived. And the relation between step and ramp signal, we have seen ramp signal as the integration of the step signal. In this lecture, we are going to cover addition and subtraction of signals, discrete time, and multiplication of discrete time signals. To illustrate this, I am considering two sequences x1 of n and x2 of n. And the problem is to find a sequence P of n. To find a sequence P of n, which is the sum of the two given sequences x1 of n and x2 of n, and Q of n, which is the difference between x1 of n and x2 of n, and S of n, which is the product of x1 of n and x2 of n. The sequences given are x1 of n given by this sequence, and this sequence has n is equal to 0 here, and it has values for negative values of n and also positive values of n. And x2 of n, no arrow is given. It is implied that the first one corresponds to n is equal to 0, and this has no values for negative values of n. The graphical representation of this x1 of n and x2 of n are shown here. So x1 of n ranges from minus 5 to plus 9. So at minus 5 its value is 4, at minus 4 it is 3, at minus 3 it is minus 3, at minus 2 it is minus 1, at minus 1 it is 4, and at 0 it is 1, and it continues. And x2 of n starts from 0, it ranges from 0 to plus 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And at 0 its value is 1, and at 1 it is minus 3, and at 2 it is 2, 3 it is minus 5, at 4 it is plus 5, at 5 it is minus 1, at 6 it is plus 5, at 7 it is minus 1, at 8 it is 0, and at 9 it is plus 3. So let us take these sequences and tabulate them. To perform any operations, addition, subtraction or multiplication, the operation has to be performed corresponding to any sampling time, taking the samples at a particular sampling time. To do that, I have considered this table, tabulated these two sequences in a table. So I have taken n ranging from minus 10 to plus 9. And x1 is actually extending from minus 5 to plus 9. So it starts from minus 5, and below that, since it is not present, we can take it as 0. So from minus 5 to plus 9, I have tabulated the sequence x1, and similarly x2 I have written in the second column starting from n is equal to 0, because it extends from 0 to 9. To add the two signals, consider the signal it is starting from minus 5. At minus 5, x1 is having values 4 and x2 is 0. So sum of the two is 4. At minus 4, x1 is 3, x2 is 0, sum is 3. Continue like this. At n is equal to 0, both are having value 1. So the sum is going to be equal to 2. At n is equal to 1, it is minus 1 minus 3. So sum is minus 4. So we have to do the addition taking the samples corresponding to the sampling instant. So consider any sampling instant, say 4. Take the sample value of x1, sample value of x2 and perform the operation. Here it is the sum we are finding. So add the two, we get the result. So when we plot the result, see the last column represents x1 plus x2. Plotting of this x1 plus x2 looks like this. At minus 5 it is 4. From minus 5 to minus 1, whatever was present for x1 will be present. And from 0 to 9, the signal sequence values are varying since we have both the sequence samples present from 0 to 9. So this is the resultant signal x1 plus x2. So now let us consider to find out the difference between the two. So again consider the same table with n, x1 and x2. Now we have to find the difference x1 minus x2. So consider these samples. At each sample find out what is the value of x1, what is the value of x2 and subtract x2 from x1. So here at minus 5 we have x2 is 0, x1 is 1. So x1 minus x2 is 4. And it continues up to minus 1. And at 0 x1 is 1 and x2 is 1. So the sum difference is going to be equal to 0. And at 1 this is minus 1 of minus 3. So it's going to be 2. So perform the subtraction considering each instance or each sampling time n and the corresponding values of the signal. So the x1 minus x2, last column gives the x1 minus x2 which is the resulted and that is plotted in this graph. Similarly, again let me take n, x1 and x2 and in the last column I will write x1 into x2. Since x2 is 0 up to minus 1, the product of x1 and x2 is going to be 0. So at minus 5, 4 is the value of x1, 0 is the value of x2. So 4 into 0 is 0. So similarly up to minus 1, 4 into 0 is again 0. So we will have 0 up to minus 1. At 0, both are having values 1 and 1. So product is 1. And at 1 it is minus 1 and minus 3. So product is plus 3. So at 2 it is 2 and 2 plus 4. And we continue like this and find out all the product terms. So last column gives the product of x1 and x2. And a plot of this last column versus n is given here in this graph. See at n is equal to 6, its value is 25. At n is equal to 6, its value is 25. And the last value is minus 3, minus 1 into 3. So that's all for today. Thank you for watching. If you like this lecture, give a thumbs up, share it with your friends. Don't forget to subscribe and also press the bell button so that you will get the notification of the lecture upload. And to download this video, link is given in the description box. And if you have any comment, please leave it in the comment box. Thank you. See you next time.